All right, here we go. Here we go. Great. All right, so today is looking at absolute value. Actually, this 2.4.2 has a couple different topics. Today we are tackling the absolute value component. And we'll go a little bit deeper, but today, basically, we're going to get to the point where we can graph with two variables. So just have the title at the top and this first asterisk here. So looking at this, the absolute value is equal to the distance from 0. It's always positive because I'm talking about the actual distance from it. So thinking about this, if you had 0, you had 5, you had negative 9. Say if you had to get a piece of string, you had to get a piece of string and you had to start at 0, how long would the string have to be if this was, say, in feet? How long would the string have to be to go from 0 to 5? 5? Okay. Easy, right? Easy. So we got 5. All right, if you had to go from 0 with the piece of string all the way to negative 9, how long would that string be? 9. So you can see it's not ever going to have a negative number there because we're talking about actual distance, something we can measure. Okay. So let's stop right there with our idea. I want to kind of review back to something that you likely saw last year. This is when we only have one variable. And I'm going to tell you very, very clearly here that our classwork and homework is always dealing with two variables. But I want us to review and recall how we're going to figure out one variable. And this is going to help us with our overall kind of conceptualization of absolute values. So let's look at this real quick. Let's see. What two values inside the absolute values symbols here? What are my two values I can have that would allow me to end up with positive 16? What would have to be here under my hand? 4. That's if we were taking the squaring it or square rooting. Not quite that same topic. You're giving the answer to this. Great. Okay, so you're ahead. Let's go back in time first. All right. How about this? There's nothing there now. There's nothing there. What are my two numbers I could put in here? Let's say. What's one number I could put in here in order for me to take the absolute value of it and get 16? 16. That's easy, right? 16. What's the other number that I could put in there to take the absolute value of it and get positive 16? Negative 16. So you see that whatever's on the inside, there's a positive and a negative option for me to absolute value it and get a positive. Okay, so let's just look at what we had to start. It was x minus 4. And now looking at this, I know that I like blue pens better than green. Great. I know that this in here, whatever expression's on the inside, it can end up being a negative 16 or a positive 16, right? So if this was positive or negative 16, I end up with my positive 16. So what we're going to do is we're going to make a positive branch and a negative branch. Okay. The positive branch, again, is just looking at this 16. It's going to be 16 is equal to x minus 4. The negative branch is going to have negative 16 is equal to x minus 4. So if we look at that, what we're saying is, when does this expression equal positive 16? When does that expression equal negative 16? We find those two options and we know the two numbers that work in this problem. Okay? Let's see. Plus 4, plus 4. All right, we have 20. Plus 4, plus 4. And now, Zarafshan, where you are in the future. The future has arrived. And now I understand why you all said that. Great. All right. So you see, when we have one variable, we just have to remember that whatever's on the inside, it could be a positive 16. We get it. A negative 16 also gives it to us. So we have to have those two options figured out. Okay. So this is kind of just a segue because this is only one variable. But from here on out, we're going to be dealing with two. Just want to slowly build you up. Thumbs up, sideways down for this one variable. Looking good. I'm going to put it over here. And a bit further over here. All right, let's look at the next component here. Now we're dealing with two variables. We're dealing with two variables now. When I'm looking at this, first off, we're going to graph it, so I want to know what does the shape look like. Okay, the way to remember the graph shape is going to be, you can write absolute value. See how the V has rays on it? Because the absolute value, the graph always looks like a V. Okay. It has this center point called the critical point, and then two rays that emit out, up or down. Okay. One or the other. So this might be helpful. I'm going to write it here. Okay, so that's one way for us to remember. Value kind of looks like the shape we're making it. Okay. Here is the two variable formula for absolute value. We need this in order to look to see what our A value is. And later, tomorrow, we'll get to what the H and the K actually do to it. What we'll see is that the H and the K move it up, side to side. It transforms it in different directions. Okay, but to start, we just want to have this as part of our notes for today. We'll access it tomorrow. All right. So looking at this problem, my A value is whatever is right in front of the absolute value. Okay, so my A value is just whatever is in front. If there's nothing out in front, it's just equal to 1. Right? If it's negative, it would be -1. So we need to know that because similar to with parabolas, when we had parabolas and A was positive, was it happy face or sad face? When A was positive, it was happy face. It was curving, opening up, right? If A was negative, it was sad, right? It was opening down, it's curving. So the same goes with our robots, because robots don't smile like regular people. So we have a bad robot. If our A, excuse me, that says good. We have a good robot. He's like, I'm not bad. We have a good robot if A is positive. Okay. If A is positive. Bad robot if A is negative. Bad robot. And then we look a little bit closer, just from our A value, we can find one other thing out. Think of the parabola when it was opening up. Did we have a minimum or a maximum? When it opens up, minimum or maximum? Minimum at the bottom, right? And that's easy to see if you have a graph. You can see that quickly, right? So what we know is if A is positive, it's going to be opening up. So this extrema is going to be the minimum. Okay, the extrema, just remember that's the maximum or the minimum. It's one word that we talk about, that we use when we're not sure which one it is. So the extrema for A being positive, opening up here, is a minimum. And how about right here when A is negative, we have a bad robot, frowning, then we have a maximum. Okay. So just from our A value, we can find out all that information, which helps us quite a bit. Then we know how to start the graph. Start to graph it. All right. So let's start with, not that one. Let's start with this one. We're going to move over. And that should be okay. All right, we're going to work out this problem together using all the points, and I'll get to the next steps right after this. So first off, we can do step 1. Let's look at this problem. Good robot or bad robot, and how do you know?
Good robot.
Because?
If A is 1.
The A out here is 1, right? So I know that my step one of working through these types of problems is to look at this and say A is positive, so we have a good robot. All right, A is positive, so do we have a minimum or a maximum? Just look at the shape of the smile. Yeah, minimum. I knew that would be pretty easy thing to translate from a parabola work. All right, next we need to look at the next step. And just like with parabolas, what was, with a parabola, what was the bottom called? It was the minimum, and it's the vertex, okay? So with absolute value, it's kind of a similar concept, but it's not called a vertex. It's called the critical point. The critical point is at the minimum or the maximum. It's at that, well, it is a vertex of two rays, but we're going to call it the critical point. All right. To find the critical point, now that we've done step one, we know it's a good robot that has a minimum. We're going to set the expression inside the absolute values. Inside, we're going to set that equal to 0. And actually, I think to make this clearer, I can say that is going to be equal to 0, whatever it is. I'll leave it as blank box because I don't want to add variables.
So
Question.
like x would be 0, right?
So remember, it's the expression inside the absolute values. We're going to make it equal to 0 to be.
Oh.
So what is actually inside the absolute values? What's the entire expression inside the absolute value symbols? There we go. So we're going to take x plus 5. There we go. So I'm going to take this. X plus 5 is equal to 0. All right. What I'm doing right here in my second step, remember, is finding the critical point. So my critical point, remember, is going to have an x and a y. So here I'm just going to figure out my x, and then we'll get to the next step. So for this, we're going to subtract 5. So I just found out my critical point has an x value of -5. This is the step for finding the critical point. And really, this is going to be the first step we do every single time. From there on out, you'll see it's very similar. We're just going to be plugging in 2 other points that we get to choose even. So what I just did, I found that expression inside the absolute value symbols, and I made it equal to 0 to find my x. Now what do? Plug into the original to find your y. So I'm going to take my original equation, the original, and I'm going to go ahead and plug in -5. I'm going to plug in -5 where I had my x value. So we can make it y. We can also call it f of -5, which helps us remember what we plugged in. It doesn't matter. They're synonymous. That's just function notation. We're going to end up solving this, and that'll be our y value that goes right here. All right, what do we have inside the absolute values? -5, +5 gives us 0. Absolute value is 0. Is 0. So we just found this point. And this is the key point because remember the critical point is really what we needed to start our graph. Let's go ahead and graph the critical point. -5, 0. 1, 2, 3, 4, 5. That's my critical point right there. So you know that the graph's going to look something like this. It's going to look like a V. It's going to go up and out. And really what we need to do now is figure out what are 2 other points. Because if I have one other point on this side, I can find this ray. If I have another another point on that side, I can find that ray. Okay. So let's look. We have that done. Step 3 now is to find those 2 points on each side. Okay. What we're going to do for that, hear me out on this, because after I describe it, it'll be really clear, I'm sure. It's hard to write though. We're going to find a point left, which is less than, and right, which is greater than the critical point, as far as finding some x values to plug in. Okay. So what we have, we found our critical point was at -5 and 0. So just looking at my x values, what is one x value I can use? I can decide. You can choose anything. What's one x value that is less than? That's less than to the left on my number line. It's to the left of -5. What's one number that's less than that?
Negative 8.
Yes. -67. So you can choose anything, and you choose that one. That's great. That's great. You could have chosen -6, -10, -12. It's just one number that's to the left. Okay. You don't have to use -67 if you don't want. It won't make a difference. So it'll just be harder to graph. All right. What's one number? What's one number that's to the right of -5? So I can even make my number line if I'm confused. So what's to the right? What's the easiest number to deal with that's to the right?
0.
0. If we can use 0, let's use 0. Because I know that could eliminate some other components of my expression. So just for Udiel, I'm going to go ahead and do f of -67. -67 plus 5. -62. 62. All right. All right, what's next? I just found my first point. That helped me find my first point. I need one more point, right? One more point. How do I find f of 0? I make it, or I evaluate 0 for x. And we get the absolute value of 5. We get 5. So one point is really easy to graph. The other point we're going to estimate. Or maybe I'll ask somebody else for another point. All right, let's do this bottom one first. 0 for x, 5 for y. 0 for x, 1, 2, 3, 4, 5 for y. Right here. Okay. So I can already see that since this is the critical point, whoa, did like an angled sine wave. It still is. All right, I know that's going to be one branch. Now, one thing we do know is that there is some symmetry around these two rays. I know that they extend from the critical point at a similar angle in both directions. Okay. I just want you to have that in mind, because if you worked out your second ray on this side and it was going something like this, right? That's where you want to be skeptical of it. We know that it has to be approximately the same angle extending out. So if you end up with a ray that doesn't make sense like that, just know, yes, it is symmetric on both sides. Okay. We're not going to call it a line of symmetry, but we're going to notice symmetry whenever we can. Helps us know if it's right. Yeah.
Wait, so do you only need 1 point? Because then you can just reflect it.
Right. We're always going to do 2 points, so we're completely exact.
Oh.
Right. So let's try to graph -67, 62. I'm going to humor this. All right. Let's see. That's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. All right. That's -67.
You're gonna run out of time.
Woo! We can do it. All right. That will just about do it. If this is 67.
You're gonna run out of time.
Ah. All right, there's our other point.
Okay.
Now, I don't want to make a line all the way up there, so mechanical advantage.
Nice.
All right, can you line up those 2 points, that one and that one?
Okay.
All right, so if you did count all the way out there, if you were doing -67, 62, it would approximately be like that. All right, we got it. Okay. So who picked another number, not -67? Anybody? -10, -6, all those would work. What I'm saying is those are points on the graph. We just had to figure out what x value we were going to plug in. All right. Okay, the last step for these type of problems, then we'll try one additional problem, is to figure out the domain and the range of this function. Remember, domain is our x, range it talks about our y values. But let's look at this closely, because the domain Think of the domain. This extends out, it extends up. So watch this. This extends out and up. Does it ever stop moving over to the left?
No.
Keeps going forever. Just like a parabola, remember it opened? If it goes to the right, it keeps going up. Does it extend over? Forever, right? So I know that my domain, my x values, all real numbers. R with the double line there is real numbers. We could express it negative infinity to positive infinity, but all real numbers gets it done really quick. Now let's look at the y, the range. So follow me with this. If I'm down here at my y values of negative 10, if I'm at negative 10 for my y, am I on the graph at all?
No.
I'm not touching it at all, right? What if I'm at negative 5? Am I touching it yet? Am I touching the blue graph? How about negative 1?
No.
How about 0?
No.
Yes.
Oh, yeah.
Right? Because that's where the point lands right there. So as far as my range goes, it's from 0. And doesn't it keep going up all the way because these keep going out and up? You agree with that? Okay, so I know that my range, watch this close, y is greater than or equal to 0. Because I look to see where on my y coordinates here, when do I actually touch the graph? It's right here at 0, and it's all the y values that are above it. So we just did it for this problem. We did it. All right. We have one more. No applause, no cheers. Yay. Yeah. One more, yeah. Not everyone bought into that, I could tell. All right, let's do this one because it's slightly different. What is the one thing that's different we could see right off the bat? All right? All right. Uh-oh. Okay, so we know that A is negative. So good robot or bad robot? A is negative. Bad robot. What does that tell us? Minimum or maximum? Maximum. All right. Next, let's find the critical point. How do we do that? Step 1. Sorry, that was step 1. Step 2. We take this expression, whatever's inside, make it equal to 0. So we know x is equal to 3. So our critical point, 3 something.
Excuse me.
I know the x value. How do I find my y? Good. I take the original and I plug in f of 3. Negative 1, 3 minus 3.
Wait, with that, is that like distributed?
We didn't distribute. Actually, we evaluated. We plugged in 3.
No, I know, but like with the negative 1, that's not.
We don't distribute. No, we don't distribute. Good question. Absolute values do some things. They act like parentheses in a lot of ways, but we're not going to distribute the negative 1. What's 3 minus 3? 0. Negative 1 times 0, 0. So I just found out my critical point is at 3, 0. So let's go ahead and graph that point. 1, 2, 3, 0. That's my critical point. All right. Now we go back and we look. We can make a table. We know that we have 3, 0 on that. What is one x value that is to the left that's less than 3 that's really easy to work with?
0.
Good. What's one number that's greater than 3 that's pretty easy to work with?
4.
Good. I like it. You can pick any numbers. You don't have to pick negative 67. We picked 0 and 4 because those are pretty easy to evaluate. So now we're finding those other points. We're going to go ahead and plug in f of 0, negative 1, 0 minus 3, What is the absolute value of negative 3?
3.
So the absolute value of negative 3 is 3, but we multiply it by negative 1, so we get negative 3. All right, so I plug that in, I got negative 3. And sometimes you see patterns up here, but don't depend on those patterns. Wait to see it a bunch of times. This isn't always going to, flip it or do anything like that. All right, how about, let's plug in 4, f of 4, negative 1, 4 minus 3, negative 1, absolute value of 1, so we end up with negative 1. Right, I didn't put that last step there, but the absolute value of 1 is 1 times the negative 1. That's how I got my negative 1 there. Okay, great. Negative 1. All right, we graphed those other 2 points, and now we'll be able to make our graph. So let's go 0, negative 3, 4, negative 1. As long as we remember what the critical point is, that's why we label it out like so, then we're pretty easily going to be able to graph those. All right. Very last step, step 4. Domain and range. What's my domain with my x values? All real numbers. How about the range? Where does it start? When do I, along my y values, way up here, nothing on the graph. How about at 5? No. How about at 2? How about 1? No. 0. It's 0 down. Okay? So we have y is less than or equal to 0. Done. When we did this one, it seemed quicker, right? It's actually, once you get the critical, find 2 points, you're done. Yeah, question?
Is the domain always going to be all around
It is for absolute value. Yeah. Until you start rotating it. But let's get to that later. All right, the other class likes to say something at the end of the video. Does anybody have any good ideas? What you want to say? I just whisper it. We'd like for you. Do you want to come whisper it to it? Come on up. No?
You should ask if my
Oh, just do that?